Hello, this is Mr. Stansbury. I'm going to take you through the 19H assignment and go through any problems that you might have. All right, so let's see. First problem, number 1, find intervals where f of x is increasing and decreasing. So here's our first problem here. You'll notice it starts right here when x equals 0. We don't really care too much about the y. We just care about the x value. So it starts right after, actually when x is greater than 0, and it increases forever. So part I is going to be that it is increasing when, let's see, x is greater than, not equal to, because notice it's open circle, greater than 0. And then for I on that one, there is no spot where it's decreasing, so we just put none. Okay? For B, we've got, let's see, it's increasing, never, because it starts here and it's going down, so it's never increasing. And then the decreasing part is basically, let's see, when x is greater than -2 but not equal to, because again it's open. So let's see, x is going to be, we'll make a little double inequality here. So when x is greater than -2, and then also when x is less than but not equal to 3. So that the whole thing is decreasing because it's going down as you're going left to right. Okay. Third one, it is increasing from -2 all the way up to just before 0. Because really at 0 it's perfectly horizontal and it's not increasing or decreasing. So it's going to be increasing when x is greater than -2, but again it's open circle, so it's not equal to, and then also when x is less than 0. Okay, and then it's decreasing when, now the rest of this way here it's decreasing, so x is going to have to be greater than 0 but less than 2. Alright? Okay. Let's see, let's look at D, E, and F. Okay, so, oops, sorry. So it is increasing when, let's see, it's basically, notice it's got the arrow here, so it goes on forever and ever. So it increases basically when x, as long as x is less than, the x value up here is 2. Whenever the x value here is less than 2, at any point along here, again, always as you're reading left to right, this thing is always increasing all the way up until x turns into 2. That's where it is horizontal. And then it starts decreasing at any point when x is greater than 2. Because again, as we're greater than 2 out here, then the function is decreasing forever and ever. All right? E. When is this increasing? Never. Okay? Because this thing is going down the whole time. And really, it's decreasing. If you'll notice, there's an asymptote there. So it's getting ever so close to that line, but never actually crossing it. So it's actually decreasing for all real numbers. It's always, the function is always decreasing. It's always going down as you're going left to right. Okay? F, it is increasing all the way up until we get to 0 where it flattens out, and then actually it's increasing after that too. So really, I would go with it's increasing for all real numbers except for 0. Okay, and then again it's not decreasing at all, so we would go with none on that one. Alright? And really, I suppose instead of none, we should be putting that it's never increasing on that one. On this one here, it's never decreasing. Okay. All right. One more set of examples for one. Well, not examples, but for problems for number 1. So, when is this thing increasing? So again, as we're going left to right, decreasing, decreasing, decreasing. So it is going to be increasing from here to here. Notice it's going up at that point, right? And then from the beginning all the way down here to 1, it's decreasing, and then after 5, it's also decreasing. All right, so let's write that down there. So increasing is this section in here. So it's increasing when x is greater than 1. There's our 1. And then when it's less than 5. And then it's actually decreasing in 2 different spots. It's decreasing when x is less than 1. Right? And it's also decreasing when x is greater than 5. Okay? All right, here's h, although it actually looks like n, but it's actually h. So let's try that one out. So let's see, we are increasing on this thing here. Again, as we're going, let's just start from the far left and go across, and we'll figure it out from there. So this is decreasing up to this point, and then also right here decreasing up until we get to 2, and then that's where it starts increasing, right? And then if we go over here, it's also increasing. All right, so we're looking for the increasing parts first. So here it is right here. That is when x is greater than 2, right? Except for it also has to be less than 4, right? Because that's our asymptote at 4. So let's do this. Let's rewrite that as a little double inequality. So again, x has got to be greater than 2, but it has to be less than 4 is the first spot there. And then also when x is greater than 4, right? And actually it goes on to infinity because it's got the arrow there. Okay, so x is greater than 4, and then also when x is between 2 and 4. These are the 2 spots where it's increasing. All right. The spots where it's decreasing here is when x is, let's see, as long as it's less than 0 here, right? As long as it's less than 0, that takes care of this first part here. And then also when x is greater than 0 right here, but less than 2. Okay, so those are the 2 spots where it's decreasing. Decreasing there, decreasing here. Okay? And then we got I. So let's see, increasing. Let's see, let's put our little arrows on there to hopefully help out. Increasing here, decreasing there, increasing here, decreasing there. Okay? So we are increasing when over here all the way whenever it's, as long as it's less than 0, right? Because it looks like that's right at 0. So when x is less than 0, it's increasing. And then it's also increasing over here when, let's see, x is greater than 2 right here, and then it's less than 6. Okay? It is then decreasing when, let's see, we got x has got to be greater than 0 right here, and then it's less than 2. That's our decreasing point. And then also it's decreasing when x is greater than 6. Okay, again, this 5 and the negative 2 is just basically giving us the height here. The main thing that we're concerned with is the x values. All right? Okay, let's take a look at number 2. Oh, sorry, not number 2, but the second number 1. Okay, so we're going to find intervals when f of x is increasing and decreasing. All right, and then our quickest way to do that is really just to do that on our graphing calculator. All right, so let me see if I can make this fit a little bit better. Okay, so let's start with a here. We're going to go into the y equals, And then you're going to want to enter these into your graphing calculator, or you can do it on Desmos as well. I've already pre-entered all of them in. So I've got the first one is x squared. So again, most of these should work pretty well with Zoom Standard. And look, there it is, Zoom Standard. So if you'll notice, it looks just like the other example that we were doing. The only problem is it doesn't give us any of the actual coordinates, so we just kind of have to figure out what those are. Again, as long as our scale here, our x scale is set by 1, that should make it pretty easy. We should be able to just count the tick marks. Okay, so find when it's increasing and decreasing. So let's do A. We've got is increasing and when it's decreasing. All right. So it is decreasing right here at the beginning. So let's start with that one, and again, this is a parabola, it goes on forever and ever. So it's decreasing basically whenever x is less than 0. So decreasing when x is less than 0, and then it's increasing on the other side over here. So that's increasing when x is greater than 0. Right? So x is greater than 0. So there's A. Okay. B, I'm just going to kind of flip this back and forth so that we can see those. Go back into y equals, and I'm going to turn off that graph and then turn on the B graph. And then here's what the negative x cubed graph looks like. So if you'll notice, it goes down, and then it's going to have a little spot right here at 0 where it stops going down, and then it starts going down again. Right? So this basically, for B, is going to be, so increasing, none, or no, that's right, we figured this out. We're not going to write none, we're going to write never. It's never increasing. But decreasing, it's going to, again, to look at the graph, it's decreasing basically forever except for at 0. So it's decreasing for all real numbers not equal to 0. Okay? C, go back in here, turn that one on, off, turn this one on, and graph that one. And this is the 2x squared plus 3x minus 4. So again, looks like it's decreasing all the way up until this point right here, which again should be, looks pretty good like that is going to be at -1. I'm just going to double check it really quick. I'm just going to calculate the minimum just to make sure. Okay, so find our minimum, and it is at, ooh, look, x is actually at -0.75 instead. So good thing we double checked. So it's decreasing all the way up until, again, it's -0.75000. We'll just assume, we'll just round it to -0.75. So it is going to be decreasing before, when it's less than -0.75. So let's see, we'll write increasing and decreasing. So again, on our graph, oops, wrong one. Let's get rid of that. Oops, sorry, that's the other calculator. So it is decreasing when x is less than -0.75. So x is less than -0.75 is when it's decreasing, and then it's increasing when x is greater than -0.75, right? Because it's just increasing on the other side of that. All right. Let's take a look at D. All right, let's graph that and see if this shows up okay. Ooh, okay, so it's increasing up to this point, decreasing, and then somewhere down here there's a minimum. So let's fix our window so we can see that a little bit better. So we want our y minimum. We need to go down farther. Let's try -50 and see if that works. See if that gives us a good enough view of it. There it is. Okay, we don't officially need to see it, but it just makes it a little bit nicer when we're finding it. Okay, so let's start with this. C, we got increasing and decreasing. Okay, so on this graph here, increasing all the way up, and that's definitely right there at 0. Okay, so we've got, well, I guess really I shouldn't say definitely. Let's double check it. Second, calculate. Let's find the maximum. Be embarrassing if I was wrong, which you know that I'm wrong a fair amount, and that's all right. Oh, let's see. Oh, there we go. Negative 1.4, blah, 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 blah. E to the negative 6. So that, remember, that's 0. That's just kind of a TI-83 glitch that they have. So the X is 0. So it's increasing all the way up as long as X is less than 0. So X is less than 0 is increasing. That's one spot. Okay. Then it's decreasing from 0 to whatever this point is here. So let's figure out what that is. So let's calculate that minimum. All right. So we get over here, get past that minimum, and find out that the minimum value there is 3.999. That is 4. Okay. So it's decreasing when X is greater than 0 but less than 4. And then it stands to say that it's going to be increasing after 4. Okay, so then as long as when X is greater than 4, it's also increasing. All right, oops, I put C on there, but that's really D. All right, let's try E. All right, turned on that graph. Oh, not terribly helpful. Let's zoom standard on that one. I think that should get us what we need. Yep, there we go. There's our minimum, there's our maximum. So it starts off decreasing there. So let's do increasing and decreasing. Let's find what that minimum right there is. Okay. Alright, so that minimum there is at negative 0.8. Let's go with negative 0.82. So it is decreasing as long as X is less than negative 0.82. Okay, it's then increasing from negative 0.82 up to whatever that maximum is. So let's find that. Alright. Find that maximum point there is positive 0.82. Okay. So it's increasing from negative 0.82 to positive 0.82. Increasing. Oh, look, I wrote the increasing on the wrong spot. So this here's got to go down on the decreasing. I wrote it on the increasing. So let's fix that. Oops. Let's see. Let's get back out here. Sorry about that. Uh-oh. Hit too many undos. There we go. Alright, so that was decreasing as long as X was less than negative 0.82. And then we just saw that it's increasing from negative 0.82 to positive 0.82. So when X is greater than negative 0.8, oh man, didn't leave myself enough room. Let's see if I can not do too many undos on this one. Okay, let's try this again. So it's increasing when X is greater than negative 0.82. There we go. And then it's got to be less than positive 0.82. Okay, so that's when it's increasing. So we got decreasing, increasing, and now we got to get the last decreasing. So that's going to be right here after the 0.82, right? So as long as X is greater than 0.82, which is, that's a 2 there, sorry. So as long as x is greater than 0.82, which is right there over here, that's all the time where it's decreasing. All right? Okay, let's take a look at the next one, which is f. Okay? So let's find that. Y equals, let's figure this one out. We can graph that one. Ooh, again, now that one looks like that goes way up there. So again, got to change our window. So I want to be able to see farther up. I'm going to go with 100. See if that gets me far enough up there. And it does, so I can see the top. So this one is going to be decreasing when x is less than whatever that minimum point is. So let's figure that one out. All right. Okay. So decreasing as long as x is less than negative 0.5. So let's write it on the right spot this time. It's decreasing when x is less than negative 0.5. Okay. And then it's increasing from our negative 0.5 to whatever that max is. So let's find that maximum. Okay. So let's see what we get here. And that maximum is when the x is 3. Okay, so it's increasing from negative 0.5 to 3. So it's increasing from negative 0.5 when x is greater than that, and also when x is less than 3. Okay, and then the last one here is when it's decreasing when x is greater than 3. So x is greater than 3 is when it's decreasing. Okay. All right, let's take a look at G. All right. And we'll graph that one. Oh, I keep forgetting to fix the window. Sorry, let's do zoom standard and hope that shows up. And look, there it is. There's our maximum, there's our minimum. So this one's starting off by increasing on the first part, and then it's decreasing on the second part. Alright, so let's see, let's find out what that max point is so we can see how far it increases to. Alright. So let's see, that maximum is negative 2.618. Let's go with negative 2.62. So as long as x is less than negative 2.62, it's increasing, right? And then it's decreasing from here down to there. So let's find that minimum. All right. So we just keep tracking over there. And that minimum value there is when x is, let's go with negative 0.38. Okay, so it's decreasing from this negative 2.62 to negative 0.38. Okay, so negative 2.62, x has got to be greater than that, and that's got to be less than negative 0.38, is that right? Yep, 0.38. Okay, and then after the negative 0.38 is when it is then increasing again. So when x is greater than negative 0.3, I'm going to turn that out, there we go. 38 is when it's increasing. All right, last one here, h. Let's see. We need our calculator. Let's pull that up. And then the last one here. Turn that graph off and turn this one on. Zoom standard just to make sure. Let's see. All right, we got our maximum, and then we got a minimum way down there. So let's. Doesn't look like it's super far down there. So let's change our window minimum to say maybe negative 25. See if that works. Yep, good enough. So maximum looks like it's just to the right of 0. Let's find out. So again, increasing and decreasing. All right, so let's find that maximum. Okay, make sure that we're to the left of the max and then to the right of the max. And so it's increasing all the way up to 0.27, it looks like. And that's increasing, right? So as long as x is greater than 0.27, then it's increasing. Right? Yep, positive. All right, and then it's then decreasing from 0.27 to whatever that minimum is. Let's figure out what that minimum is. Okay. Oops, we want to go this way. Looking at the minimum. Okay, it's past the minimum. So we can figure out what that one is. And that's 3.73. So it is decreasing when x is less than, greater than 0.27. And x is greater than that, but then when x is less than, what was our value? 3.73. Okay. And then the last part here is increasing after that 3.73. So when x is greater than 3.73, then it's back to increasing. Okay? All right, that is all the problems on 19H. Be sure to ask if you have any more questions. Thanks.